Hello and welcome to the course Design Borefields with Confidence. This is the second part where we will be designing our first geothermal system together. But before we start, let's do a small recap of what we did last time. So in part 1 we introduced this course and we also talked about why a ground source heat pump is a good idea in the first place. And we talked about individual reasons like having passive cooling, having a system with high efficiency, a high lifetime, and so forth, but also collective reasons, why we as a society should put geothermal systems forward and to try to push them as much as possible, because they lower the urban heat island effect and they are also better to overcome problems with grid congestion of the electricity grid. Next to that, we also talked about the importance of basically this course on why geothermal design, borefield design is important. And there we compared design software and results with typical rule of thumbs like 30 or 40 watts per meter. And we saw and found out that these rule of thumbs, they can either oversize or undersize your system quite significantly. So it's a little bit like driving blind. You have no idea where you want to end up. So that's important to use design software instead. After that introduction, we discussed the 3 basic input parameters you need for every geothermal simulation. So we talked about the ground parameters, the ground conductivity, capacity, and the ground temperature. We also introduced thermal response tests to measure these values in situ. Next, we talked about the building loads, the heating, cooling, and domestic hot water demand of your building. And we thought that, well, there are on the one hand hourly values available where you can simulate these in detailed simulation software, or you can use simple rule of thumb or full load hours, for example, to calculate your energy demand. So there are different ways to come up with your building demand, but in the end you always need an energy demand before you can start sizing the system. And lastly, we talked about the efficiency. Now, we talked about what has been used historically, namely the SCOP, the seasonal coefficient of performance of your heat pump, to simulate these systems. But we also talked about the dangers with that, the risk of over or undersizing, and what would be better to use modulating heat pump directly in the design software. And this is something we will come back to next part. Now, today we will be making our first geothermal simulation together. Now, before we do that, we will first dive deeper into these temperature profiles and really teach you what you can see in them, how you should interpret them, so you can get all the insights out of it. Because, this whole course will be about temperature profiles, so we need to get a really good foundation when it comes down to understanding these profiles. And this we will also do with the help of the concept of borefield quadrants. Later, we will also talk about what's behind these profiles, and we will start introducing the borefield physics. But today we will keep it simple. We will use the traditional assumptions when it comes down to borefield design, so that later on we can go to more advanced insights and teach you how basically the borefield design has changed over the years and what we are able to do now with GHG2. So we will introduce today the concept of the effective borehole thermal resistance, and in the next chapter we will also talk about the long-term effects and the G functions or the ground response functions. And we will end this part with a tutorial of GHG where you will be able to make your first geothermal borefield simulation, perhaps of your whole career. So it's going to be really exciting there. We will also again have some questions and exercises throughout this part, so you can really understand or learn what we try to teach you here. So without further ado, I see you in the first chapter.